Some of the challenges which service folks have and complexities, and I'm going to cover a couple of them, a few of them. So the first one I'm going to cover is spare parts planning. So imagine, large companies like Caterpillar, who have multi-million dollar machines, or even K-Let and Core, or even Intuitive Medical and medical device and high tech. They have high value machines, and they have millions and millions or thousands of parts. And Caterpillar, for example, is a global company, and they have multiple manufacturing warehouses. There are multiple distribution warehouses, and they would have multiple parts warehouses again in each country. And then you will also have multiple field service technicians who will have their trunk stock, and they may have third-party service providers who will also have parts as well. So, the parts can be manufactured by Caterpillar, can be manufactured by third-party vendors, and then they could, and parts could have different versions. So part A could be replaced by part B could be replaced by part C, etc. And then you could have high-value parts. You could have which you really can't stock, or you can stock in specific places. And then you could have fast-moving parts and slow-moving parts. You could have a customer who has got a very high SLA, which means you have to stock part of the customer site as well. That is another scenario which has to be taken care of. So how do you forecast and plan for such parts? I mean, you really need proper inventory. I mean, the right parts at the right place at the right time, and you need to decide how much do you want to stock at each location, or each of the warehouses, or in each trunk stop. So this is where the spare parts planning solution from Equipus can potentially help, and Ramki is going to talk about that shortly. Similarly, going on to preventive maintenance, the preventive maintenance is really based, like your car, as an example, is based on a counter, which is or a duration. So it could be 10,000 miles in a year, or it could be, or it could be 10,000 miles, or it could be 1 year. Now, whether you drive the car at all, like I have two cars, I drive one probably 2,000 miles a year, and other one probably 20,000 miles a year. But the service period is same. So this results in unnecessary maintenance, which is not really required, unnecessary cost, and it may result in failures as well, because you try to do a PM and that resulted in a failure. So that's a typical model which has been done in the past, but the new model is based on predictive maintenance, which essentially means that you do the maintenance based on the condition of the car. I mean, the older preventive maintenance was based on a theoretical rate of failure, and it did not account for actual equipment performance. So, what you have is you have various sensors, like a pressure sensor, you have a vibration sensor, you have temperature sensor, etc., which monitors the condition of the device, and then it can help you do predictive maintenance and preventive maintenance. Again, Ramki is going to cover that on details about that solution. And then the last one I will talk about is connected devices. So service has generally been reactive in the past instead of being proactive. So, I mean, how can we make it proactive? I mean, to get the right technician with the right skill set, with the right tools, with the right parts, and avoid repeat visit is what everybody would want in the service team to have, as well as the customers would also want to have that. And typically, according to a research conducted by Service Council, 77% of the time, the fixed rate, there was a first-time fixed rate. So 23% of the time, you have the technicians going for a repeat visit, or there were no parts available, or the tool wasn't available, or they did not have help from a technician. The other challenge which is there is for services embracing these new technologies. So you have these technologies of IoT, machine learning, artificial intelligence, and virtual reality or augmented reality. How do you leverage these technologies and build processes, business processes, or service processes, which makes the service organization more efficient and better? And that's where I think our solution is going to help you. I mean, our goal is to provide a solution which works with these technologies and integrates that with backend ERP, CRM, or supply chain solutions. And with this, I will hand it over to Ramki to talk about more details about the solution.
Thanks, Ashish. Clearly, we articulated the challenges that service team face. And the whole thesis behind eCrypt is how can we use the AI and machine learning so we can look at what has been deployed in the field and look at the pattern of how these assets are performing and how the technicians are both call center as well as field techs are working, and how the parts are being consumed. And clearly, if we can understand the nuances or the pattern, intricate patterns we call it, that can be more focused, and then we have an opportunity that we can essentially democratize the way that companies execute today. And improve the quality of service, also drive both the revenue as well as the customer experience from those. So clearly, if you look at almost all the companies globally, the field techs are, it takes a long time to train somebody there. And the challenges that many companies are facing is the technicians' turnover is becoming higher, the product life cycle becoming shorter. So by having these two challenges, and is it possible that we can use in a complementary way through human guidance, but really having a ML way of extracting the proper things so that we can help the technicians, we can help the logistics teams with the right parts management, we can help the call center to really solve the problem very quickly. So that's the thesis. And how we do that, we are looking at the data that is coming from the assets as well as from the internal systems that are processing them. Once we get them and we have a unique way of looking at these data points and look for the patterns and anomalies. From these, we generate some forecast signals for parts, technicians, and the problems and where things are coming. And we can also see, for in some cases, you may have to account for the lead time, replenish time, receive time. So you have to manage these things, whether the tech is available or not. If a particular job can be solved by 2 techs, which tech is better? So these type of forecasting that we can extract out. Clearly, any machine learning will have its own variance, its own incorrectness. Well, we call it, sometimes it generates false positive signals. So what we have to do, what we have done is we not only learn, we also test on an ongoing basis, so we can account for these variances and reduce the error and then drive the predictions quality up. And finally, we are able to take all this information back into the way that service organizations would want to look at the P&L and bring that proactive operational decisions. So how we are able to do in a way is described in, is within the eCrypt. So number one, we have a model, we have multiple machine learning models, but we do have a metadata that is very much of a device ontology specific. So based on the types of devices that we are managing, we are able to have apply the type of model that we need to do. And in fact, our meta model can be configured to suit for the devices that we are trying to manage. And typically, everybody looks for, today, if you look at the best practice, we all look for that time-based approach. What we have is a unique model, we call it MWBF. It is mean work between failure, with W being a very multi-dimensional thing. So we look at multiple signals. I'm just going to rattle out a few sample signals that pretty much will be obvious for a lot of people. Where the asset is, who is using it, who is servicing them, what type of firmware it is on it, what type of sensors are built in, what type of data or critical data that is coming from these devices, and what type of field work was done, what's the age, where is it, what's the environmental factor, all those types of things. We're able to take it and then apply. But all these things are just back-end model execution. But at the end of the day, the customers want to know what, how, and when type of things. What should I do? When should I do? And how I'm going to do? So we translate all these things based on the type of questions that we need to answer, bring them back to these answers or time dimensions, back into time dimensions so that we can provide them, and constantly evolve from there to learn from emerging data, new data that is coming in. And with that, we also supplement this with a lot of machine learning approach of clustering technology and pattern recognition, all those type of things. And we're able to also take the transfer learning from one set of modeling to another set of modeling, and we are able to integrate them back into workflows. Clearly, the question is, so this solution would require you to have a lot of hardware to be put in and streaming data. And clearly, if you look at it, the service has been working for many, many years. A lot of people have assets in the field for a decade or so. What that means is, what we call is, we want to work with connected devices. The requirement is, as long as we're able to track the work that's being performed on those devices, as long as we're able to get the data on a regular pattern from these devices, we should be able to work. Clearly, there is a large movement towards IoT having more sensors and streaming. So we have examples where we're able to even get the sensor data in real time, where we can take those data and look for the pattern anomaly and drive predictions. Of course, having a sensor is good, but we know that customers go through the paradigm of having connected assets, mixed assets, and then go through the IoT paradigm. So how does this solution, if you look at it, last umpteen number of years after the ERP, CRM worlds, the whole focus, we've been always focused on how to make our internal workflows more efficient. So that is the way the systems are today designed. We are now switching how customers want to see the experience of those things. If we can answer the customer-centric way, we can translate the intelligence that we're able to see and influence back into workflows, is what the big difference is with eCrypt-like solution. That way, we are able to optimize the service operations based on the patterns. We don't have to say, you know what, I have to manage all these assets. We have to do the preventative maintenance every 3 months or 4 months. We can now look at how it's being used and localized, unique pattern, and then drive them back, as an example. We also be able to get the early warnings, because it is, if you look at many of the business intelligence tools, we always look backwards. Hey, what happened last month? What happened this quarter? What happened this year? And we use that as a way to do a future planning. Here, we are able to see what is happening in the field, in the way the customers are using, in the way they are connected to the depots, and we are able to see what needs to happen from parts, assets, and tool inventory issues. We're also able to see the impact on what is going to be to my P&L, so that we can manage them better. And how do we do that? So by doing all these things, we have a module, because it's a complex, like Ashish was talking about. You have to think about the issues that are coming from there. We have to manage the assets. We have to manage the technicians, all these things. So what we have done is, we have modularized the whole eCrypt solution into various things. From the time an incident comes from the field, there are models that execute to figure out, based on the previous history, what the pattern of root cause would be. And based on that, we are also able to quickly assign. Today, for example, it takes 28 minutes to assign a rep to a problem. With this type of solution, you're essentially making it to 0. So we're able to take those problems and understand what the root cause, get the right rep assigned. On top of it, based on the past historical solutions, we're also able to figure out what the solution that might work best for this. By combining these and also adding the intelligence on the existing assets in the field, we have a device module that starts to work towards which devices are going to have a problem in the next, let's say, 30 days. Or if it's a real-time issues, next 15, 20 minutes. And where we should be paying attention to. That way, we are now going to be, we don't have to have a challenge of today, the workflows are designed. let me get the best tech available now and then send a person, right? This way, because we know where the problems are going to be, what type of problem that eCrypt is pretty intelligent enough to not just say this asset is going to have a challenge, it also will go the further down, this type of a component within the device is going to have a problem. By having that, we are able to find the right person with the right skill to deploy that. Now, that's where the technicians come in. Now I know where the challenges are. I know the capability of our technicians and the availability of the technicians and the skill sets. We can now start to look for the right type of technicians to work on them. Given that I know where the signals are coming from, where the anomalies are coming from, now we're able to even manage. We don't have to always do a rapid shipment of parts, or we don't have to do a couple of times rework at the same customer, come back. We don't have to over-replace. One of the customers that we work with, because the time is pretty sensitive, so when there is a problem, there is a new challenge of over-replacing. So instead of part A needs to be replaced because they don't want to come back and they want to make the thing very good, so they just replace part A, B, and C. So how can you avoid that? And those type of things that we can do.